All right, so now we're going to start our section on rational functions. Rational functions, again, are something you've seen before. We're building on our polynomials. We'll see that in a minute. So we want to just make sure we understand what makes a function a rational function. So what is our definition of rational function? A rational function is any function that can be defined by a rational fraction. What does that mean? That means an algebraic fraction such that the numerator and denominator are both polynomials. So let's pause, not the video, but just kind of think for a minute while I continue to talk. But I want you to think, picture what that is. As Tupac says, picture me rolling, but in this case, picture a rational function. Is it clear enough for you? Move your head to the side a little bit if you need to, but picture a rational function. What does that mean? What's a polynomial? We've talked a lot about polynomials. That's what we've been doing most of this unit so far. So it's a function where the numerator and denominator are both polynomials. So now we're going to use that definition, and I want you to try to identify which of these functions are rational functions. So pause the video, circle which ones are rational functions, unpause when you're ready to check. Okay, so hopefully you circled all of these: f of x, h of x, m of x, p of x, q of x, and t of x. So what makes these rational functions? Well, the numerator and denominator are all polynomials. Why did I use two different colors here? It's a great question. I'm glad you asked that. Glad you guys are paying attention here. So notice that the ones that I circled here in blue, those are what we typically think of as a rational function. Q of x and t of x meet our definition of rational functions, but they're polynomials also. So what we want to understand is all polynomials are actually rational functions, because I can think of q of x as 3x minus 5 divided by 1, which meets our definition of the numerator and denominator both being polynomials, and therefore it's a rational function. The same thing with the t of x. I can think of that as 3x squared divided by 1, so the numerator is a polynomial, the denominator is a polynomial. Therefore, all polynomials are also rational functions. Why is g of x and n of x not a rational function? So that's what I want you to think about, and we will discuss that tomorrow in class. So for functions that are not rational functions here, explain why they are not. So take a minute before you go on to the next video, write down your explanation. Hopefully it's relatively obvious, but if it's not, that's okay. Either way, we will discuss it in class tomorrow.